Every day, we use computers at work, in schools, and for gaming and entertainment. They help us communicate, learn, and create. But have you ever stopped to wonder how this powerful machine is actually made? A computer is not just a screen and a keyboard. Inside it is a perfect combination of science, engineering, automation, and human skill. Today, we take you inside a world-class computer manufacturing factory where raw materials are transformed step by step into the finished computer sitting on your desk. The journey of a computer does not begin on the factory floor. It starts in the design and planning room. Here, engineers carefully plan every detail of the machine. They decide which processor will be used, how much RAM the computer will have, whether storage will be an SSD or a hard drive, and how the cooling system will manage heat. Power consumption, performance, and durability are all calculated in advance. Using advanced CAD software, engineers create a digital blueprint of the computer. Before a single physical part is produced, the system is tested virtually for heat, speed, and heavy workloads. These simulations help engineers identify problems early and ensure that the final product will be stable, efficient, and reliable in real-world use. Once the design is finalized, the next step is raw material selection. Computer components are made from materials sourced from different parts of the world. Silicon is used to create processors and microchips. Copper is essential for electrical wiring and circuit connections. Aluminum and steel form the strong yet lightweight body frame. Plastic is used for the casing, keyboard, mouse, and other external parts. Each material is inspected by quality control teams using high-precision instruments. Even the smallest impurity can cause serious performance issues or complete failure later on. Only materials that meet strict international standards are approved for production. One of the most important stages in computer manufacturing is motherboard production. The motherboard acts as the brain and nervous system of the computer, connecting every component together. The process begins with a blank printed circuit board. Multiple layers of copper are applied, and chemical etching is used to carve out extremely fine circuit paths. High-speed SMT machines then take over. These machines place microchips, capacitors, resistors, and integrated circuits onto the board with incredible accuracy. This process is so precise that even an error smaller than a human hair can result in the motherboard being rejected. Next comes the installation of the processor, the heart of the computer. This step is performed in an anti-static, temperature-controlled environment. Special robotic tools carefully place the CPU into its socket to avoid even the slightest damage. Thermal paste is applied to help transfer heat away from the processor, and a cooling system, such as a heat sink and fan, is securely installed. At this stage, the computer's speed and overall performance are largely determined. With the core components in place, memory and storage are added. RAM modules are installed to allow fast multitasking and smooth performance. Solid-state drives provide lightning-fast data access, while hard drives may be added for long-term storage. The power supply unit is tested separately under high voltage and heavy load conditions to ensure stable and safe operation over time. Now it is time for the internal system to receive its protective body. Metal computer cases are shaped using laser cutting machines and treated with anti-rust coatings. Ventilation openings are added to allow proper airflow and cooling. The motherboard, power supply, storage devices, and all other components are carefully mounted inside the case. Cables are arranged neatly to improve airflow and make maintenance easier. Once assembly is complete, the computer moves to the software installation and testing phase. An operating system is installed along with all required drivers. The computer is powered on for the first time, and technicians monitor boot performance. Stress tests are then run to check speed, temperature, noise levels, and stability. Many computers are left running continuously